if you understand all the examples we just worked through on the previous page, that concept's making sense to you, then you already know everything that you need to know to apply the chain rule and take derivatives of composite functions. The chain rule itself now just becomes a formalization, one single theorem that covers each of those different properties. So our theorem for the chain rule, for some function m of x equals f of g of x. So we have this function g of x being plugged into f, so our inner and outer functions. The derivative of that function m is the derivative of the exterior function, outer function, evaluated at g of x, times the derivative of that interior function. So again, this looks a little bit different, but it means exactly the same thing as what we just established previously. But now this theorem is just more general, applies for any type of theorem. So let's look at rewriting the power rule, rules for differentiating e to the x, natural log of x, all in terms of that same notation. So the power rule, now instead of taking x to the nth power, we're taking some function f of x and raising that to the nth power, which means that our derivative is n times f of x to the n minus 1 times the derivative of that interior function. So this is exactly the same thing as what the chain rule says, just more specific for the power rule, exactly. But again, all we're doing is using the notation, the exact same property that we established before, just changing the notation. Instead of this being x to the nth power, it's some function being raised to the nth power. So our more general theorem for differentiating e to the x would be that we have e raised to some power, which means our derivative is going to be e to the f of x times the derivative of that interior function f of x and the derivative of the natural log of x, or the natural log of some function f of x, is going to be 1 over whatever that function is, times the derivative of that interior function. So we don't necessarily even really need to cover the chain rule if those general properties that we established on just the previous page make sense to you. But this is just establishing what the textbook means, or what people mean when they talk about the chain rule. It's just this idea of taking our general power rule, e to the x, and natural log of x rules, and just expanding them for when we have composite functions. Some inner function plugged into a power function, plugged into an exponential, or plugged into a natural log function.